Okay, class, welcome back. Now we're going to cover, today's lesson is going to feel like an English lesson instead of a math lesson. Because we're just going to talk a lot about lingo and how to, understand when we're talking about stuff, just so we can all have common language and know what we're talking about. So we're going to start talking about polynomials and polynomial functions. This is section 5.3. And I've written down several definitions here so that we can all be on the same page. A term is a number or product, remember that product means multiply, of a number and one or more variables. So for instance, it could be just a number, it could be the number 7, or it could be 2 times a, which is 2a, which would just be a single variable. Or it could be 1/3 times x squared y. And that has more than one variable. So those are all examples of terms. It's really important to remember that terms are separated by addition or subtraction. So if I saw something like 3x plus 2y, this is a term and this is a term. They're separated by addition and subtraction. All terms are related through multiplication or through the product of a number and a variable, or just a number. Okay, so a constant is term that is only a number. Think of a constant as something that has a constant value. Obviously, a variable, the value can change, but a constant, it can't. If I say -5, that's a finite number that you can understand. You go, oh, that value is -5. That's 5 to the left on the number line, or the value of 0.2, right? These all have specific values that you can quantify and that you can understand. So constant, there's no variable there. Okay, so what is a polynomial? Well, a polynomial can be lots of things, but it's basically can be 1 term, 2 terms, 3 terms, 4 or more terms. Polynomials is like saying there's these cars and they're called, or there's a brand of car and it's called a Toyota. So polynomials are just another type of math expression. Okay, so they're a specific type of an expression. But, well, what do polynomials look like? Well, what's important to remember is that a polynomial can't have a negative exponent. So if you were given some examples, like, is x squared plus x plus 3 polynomial? You're like, oh, I don't know, maybe. Well, you would say, yeah, it's a polynomial that has 3 terms. Okay, there you can see that they're separated by the addition and subtraction. But if I give you the example of 1/x squared and asked if this was a polynomial, then you'd be like, no, because a negative exponent is an exponent that is in the denominator, right? So, so the definition of a polynomial is the sum of terms that we just described, and that the variables are all raised to non-negative exponents. Okay, so there's no negative exponents on the variables. All right, so that's like saying, like I said, it's like saying a vehicle. Okay. Well, there are lots of different vehicles. So expressions could be equivalent to vehicles. But then if you say, well, what's a polynomial? You could say, oh, it's a Toyota. But then if you say, like, well, but what kind of Toyota? You could be talking about an SUV or a truck or a car, right? So that's what monomial, binomial, and trinomials are. So monomials are a single expression. So there's only one term, a single term. So we'll just say this has 1. Mono means 1. Bi means 2, and tri means 3. So what type of polynomial? If I have the number 3, this is a polynomial because it's a term, and it is a monomial because it is a single term. So this would be a monomial. Okay, but if I had say 4x to the 5th plus 2x minus 4x squared plus 3, then you'd say, well, is this a polynomial? Well, this is an expression that has no negative exponent on the variables and has multiple terms. Well, how many terms does it have? I say, well, yeah, it's a polynomial, but what kind of polynomial? Then you're like, well, this has 4 terms, and we haven't described what that is. Well, if there are 4 or more terms, then you just call it a polynomial. And the reason why is it just gets hard to say, like, what a quadrinomial, I don't know what they'd even call it, but poly means many, like the Polynesian islands. So you just think, gosh, that's a lot of terms, so that's a polynomial. Okay, so what would a trinomial or a binomial look like? Or what would this be if I had negative 5xy? Is this a binomial or a trinomial? And some people will say, oh, this is a binomial. And you're like, why? Well, and they're like, well, because there's 2 variables. But it's not that the number of variables that defines what type of polynomial it is. It's how they're related. You can see here that this is all related through multiplication. So this is a single term. And since it's a single term, this is only 1. So this is a monomial. So not a binomial, a monomial. Okay, well, what would a binomial look like then? Well, if I had that negative 5x, but instead it said plus y, well, these are separated, again, separated by addition and subtraction. This is a 2-term polynomial that is a binomial. Okay, so a trinomial then would have 3 terms. So let's talk about the degree of a term. One more quick thing. Monomials, all monomials are polynomials. All binomials are polynomials, and all trinomials are polynomials. These are a subclassification of a polynomial. So again, it's like if I said, well, I have a Toyota Corolla. All Toyotas are Corollas, but all Corollas, or all Toyotas are not Corollas. Okay, so all Corollas are Toyotas. There's not like a Corolla Honda or something, it's a Toyota. But if I say I have a Toyota, that doesn't mean I have a Corolla. I could have a lot of different types of Toyotas. Okay, so the degree of a term. The degree of the term is the sum of the variable exponents. It's really important that we notice this word, the variable exponents. Because if I said, well, what is the degree of the number 6? We all know that it's the same thing as 6 to the first power. And this would be the degree of 6. But when we're talking about the degree of polynomials, we don't count constant terms. So remember, if it's just a number, we don't count it. So if I have x squared plus a 3x minus 6, and I said, what's the degree of the first term? Well, this is the first term, this is the second term, and this is the third term. The degree of the first term is 2. Because this is a variable exponent here. The degree of the second term is only 1. Everyone's like, well, hold up, but isn't this 3 to the first power and x to the first power? Yeah, but we only care about the variable. Okay, and then what would the degree of this one be? Well, because this isn't, there's no x here, remember that anything to the 0 power is 1, then the degree of this variable must be 0. Okay, so a constant, we actually are going to say has a degree of 0, because we are only counting the degree of the variable exponent. So what does this sum of the variable exponents mean? So if I had a term that said, I don't know, 2x cubed y squared z, and this is all related through multiplication, so this is a single term, it's a monomial, but what is the degree this term? Well, it's the sum of the variable exponents. So in this case, it's 3 plus 2 plus 1. Well, where did I get that 1 from? The z is to the first power. So again, I'm just going to add all of the variable exponents together and say that the sum of this term, the variable exponents, is 6. So this term has a degree of 6. Okay, but what if I had instead this 2x squared plus y cubed plus z? and I said, what's the degree of the term? Well, first of all, you should say to me, well, which term? Because these are now 3 different terms. They're not related through multiplication. So I wouldn't add these variable exponents together to figure out what the degree of the term is, because this only has one variable. So the degree of this term would be 2, the degree of this term would be 3, and the degree of this term would be 1. And this would be a 3-term polynomial, again, separated by addition and subtraction. Okay, so that is how you define the degree of a term. Well, how do we figure out the degree of the polynomial then? Well, the polynomial is just going to be whatever one's the biggest. So if I have multiple terms, so say like I have -5 plus 2x minus 10x cubed plus 5x squared. Well, I can identify each one of these terms here, and then I can say, well, the degree of this polynomial is the degree of the largest term, or the largest degree term. Well, this one has a degree of 0. Remember, the constant has a degree of 0. This one has a degree of 1. This one 3, and this term is 2. So this here is the degree of the largest term, so it is therefore the degree of this polynomial. So this polynomial has a degree of 3. Well, why do we care about this stuff? Well, right now you might not, but in the future, you're going to be asked to graph stuff like this. And when you are, something you should understand is that the degree of the polynomial tells you what it will look like. So for instance, you know that if you just have a single x equals 3, that this looks like this. But if I have x squared is going to look like this. Okay, and if I have x cubed is going to go and turn twice. So what's the point of this? Well, if you take the degree of the polynomial, the graph will have one less turn than the highest degree. So this has a degree of 2, it has 1 turn. This has a degree of 3, it has 2 turns. Okay, so this will come in handy in the future. One more word that we should know that I've used a whole bunch this semester is the word coefficient. Coefficient is just the number that's attached to the variable through multiplication. So it's kind of like a term, but it's the number that's in front of the variable. So again, it's the number attached to the variable through multiplication. Okay, so you might be asked to identify the coefficient or whatever the case is. Well, now that we can tell the degree of a term, polynomials should be written in what's called descending order. Descending means from largest to smallest. So large to small is what descending means. But large to small what? Well, we're going to go from the largest degree to the smallest degree when we're writing a polynomial. So if I have the one that I had written before was something like this. This polynomial is not in descending order. If I were to put it in descending order, I would say, hey, this is the largest, so I'm going to put it first, 10x cubed. Then I would say this is the next largest because the degree, I'm going by degree. This has a degree of 3, 2, 1, and 0. So the next term would be the minus 5x squared. The next term would be plus a 2x minus 5. This is descending order, and this is how you should write polynomials. And when it's in descending order, the degree of the polynomial is the degree of what's called the leading coefficient. The leading coefficient is just the first term, okay, of the polynomial. Okay, so like I said, feels like an English lesson, tons of lingo. So let's move into polynomial functions now. And feel free to pause the video as much as you need to write all this information down Polynomial function. So what is a polynomial function? Well, it's just a polynomial that is written in function notation. So what does it look like? Well, if I have a polynomial, say that it is 3x squared plus x minus 5. This is a polynomial. Well, to make it a function, I could say f of x out here, and the function equals this. Okay, so if I wanted to find the value of this polynomial function when x is, I don't know, let's say 8. The f of 8. Well, what does this mean, this notation here? Well, this literally means where you see x, put 8. So if I want to find the f of 8, then I'd write it like this. The f of 8 is equal to 3. Everywhere I see x, I'm putting 8. Okay, and then from here, I'm going to simplify this using the order of operations. So first I'm going to do parentheses, exponents, and we're going to go from there. So these parentheses just mean multiply. So this is an exponent here, so I'm going to do 8 times 8 first. That's going to give me 64. Then we'll do 64 times 3, and that is going to be 192. Then we will add 8 and subtract 5. So we're going to get 200 minus 5, which is 195. So the f of 8 is 195. All this means is that when x is 8, the value of this polynomial expression, which is now a polynomial function because it's written in function notation, is 195. So I'll give you one to do. Tell me the f of negative 2. Go ahead and pause the video and work that out. All right, so if I do the f of negative 2, this literally means when x is 2, what is the value of this function? It's just like saying evaluate, but just plug it in and simplify. So again, the first thing here is negative 2 times negative 2. That's going to give me 4. 4 times 3 is 12. 12 minus 2 minus 5, well, that's going to be 10. Minus 5 is going to give me 5. So the f of negative 2 is equal to 5. So when x is negative 2, the value of this polynomial function is 5. So what are some applications of this? Well, believe it or not, there's a lot in real life. One specific one is understanding the projection of objects. This is the kind of stuff that got us into space. Okay, well, let's do a real simple version of flying into space. So let's say that there's an object, and this polynomial function is a function of time. So t stands for time, and we'll say that we have an object that is thrown at a height of 1,125 feet. So I'm going to stand up here on this tall pillar, and I'm going to chuck something. Okay, and it's going to go like this. And my question is, where's it going to be after 4 seconds? Like in 4 seconds, where am I? What's the height of this object? Okay, so this is a function that will tell you the height of an object when your initial height is 1125 feet and you're chucking this object, okay? And we want to know after 4 seconds. Well, where does 4 go? What does that mean? Well, after 4 seconds, since t stands for time, okay, and all of this is going to tell me the height. So we want to know after 4 seconds. So what is the p of 4 is what this is asking. Okay, so after 4 seconds, where is this? Well, I'm going to plug in negative 16, 4 squared plus 1125. not too shabby. 4 squared is 16. And times 16. So we get 256, a negative 256 plus 1125. Okay, so we are at the P of 4 is 869 feet. So if you're looking over here, this axis is time. So you're going to say, oh, in 1 second it's, you know, a little higher than 1125, and 2 it's still higher, and maybe at 3 it's starting to go down, and at 4 we're talking about being somewhere over here, right? So it looks something like this. So after 4 seconds, so this would be 1, 2, 3, 4 seconds. This is where that object would be. Okay, so that is a polynomial function, and some of the applications that you would need to do right now. Now we're going to move into adding and subtracting polynomials. Okay, and so what we need to do to add and subtract polynomials is we need to combine like terms. Combining like terms. Well, first of all, we need to know what a like term is. Well, like terms have the same variable and, this is a very crucial conjunction, the same exponents. I love Emperor's New Groove, that's where that came from. Same variable, and that's a very crucial conjunction, you know, when they're like in the little door and she's like whacking on it and it's like, let me out and I'll burn your house down. And she's like, well, which is it? Anyway, so like terms, same variables and same exponents. So question is 2x and 6x, are they like terms? Well, they have the same variable and the same exponent. The exponent here is 1. Okay, so these are like terms. Well, what about 2x and 2y? Are these like terms? Well, those are different variables, so they're not like terms. Okay, what about a 3x squared y plus a 2xy squared? Are these the same or like terms? They have the same variables, they both have an x and they both have a y, but everything has to match. So this is an x squared and this is an x. Those aren't the same. So same variables but not the same exponent. This is a y, this is a y squared. Same variables but not the same exponent. So these are not like terms. Okay, not like terms. The coefficient doesn't matter. Just because these both have a 2 doesn't mean they're like terms either. Again, it's the variable and the exponent that we care about. So if you have like terms, so they are the same variable and the same exponent, then you can combine like terms. Well, what does combine mean? Well, combine, when we combine like terms, we combine their coefficients. We combine their coefficients, not, this is really important, not their exponents. Okay, so I could go into y here, but we said these were like terms. So when I combine these, this is going to be 8x. It is not going to be 8x squared. And this is why the relationship of these x's is not multiplication. Remember that exponents are an abbreviation for multiplication, but these x's are not what's being added together. The coefficient is what's being added together. So this is like saying, hey, I've got 2 apples. And then someone over here is like, cool, I have 6 apples. And then if you're like, okay, Johnny, if we put Jane's apples together and Johnny's apples together, then how many apples do we have? You all be like, dude, 8 apples, right? Well, what we're talking about here doesn't change just because we add them together. That's the same thing. You can think of X or Y or whatever it is as an apple, but when you add them together, you're not going to change it to apples squared. It's just an apple. Okay, so it's going to keep the same exponent, but you're going to combine the coefficient. Okay, so you're going to have several problems then that ask you if stuff is a like term. Oops, I shouldn't have erased that. Combine their coefficient, not their exponent. Okay, so there's going to be several problems that are like, okay, are these like terms and can you add these together? So something like, I don't know, like this. It'd be like, can we simplify this polynomial expression by combining like terms? Well, are they like terms? Are these like terms? Well, they all have x's, but what we're looking for is the power. So these powers are the same. The variables are the same. We've already verified that. Now we need the same exponents. Because these are the same, I can combine them. But when I combine them, I combine just their coefficients. So negative 12 minus 2 is a negative 14, but I'm still talking about x squared. Okay, so that is combined. Well, these are x to the first power, so I can combine these two terms. I can combine 6x and 5x. Well, 6 plus 5 is 11, and I still have x. So this is the simplified version of combining these like terms. All right, so we could also do this as like polynomials. So instead of being a single thing, I could say, well, let's add this polynomial together. 4x squared minus 2x plus 3. And I want to add that to the polynomial negative 7x squared plus 5x minus 6. Okay. Again, it doesn't matter if these are like separated out. The bottom line is that I'm adding these, and when I'm adding them, I'm combining like terms. Okay, so I'm going to say, hey, these terms are the same, so I'm going to combine them. 4 minus 7 is a negative 3, but that's still x squared. I'm going to say, oh, hey, these are the same. They both have an x to the power of 1, so I'm going to combine those. Okay, well, negative 2 plus 5 is a positive 3. The variable is still just x. And then I've got 3 plus a negative 6. Well, 3 plus a negative 6 is a negative 3. Okay, so this is combining like terms when I have an add sign here. But what happens if I have a subtract sign? Well, what does this negative right here do if I have in parentheses x squared plus 2? What would this negative on the outside do? This means literally the opposite of each of these, and I would distribute that negative. So right now this is a positive x squared, but when I distribute it, it becomes a negative x squared, and this becomes a negative 2. This negative belongs to both of these things because it's in the parentheses. Okay, so negative polynomial is the same thing as saying subtract this polynomial, but remember that everything after is going to be subtracted. So how would this look if I were asked to do this problem? Okay, and keep in mind these won't always be given to you in standard form. So you might be given something like let's do this. Okay, and then we want to subtract here, and we're going to subtract 5 plus 2a minus 3a cubed plus 6ab. Okay, so actually let's add one more on here. We'll just do a minus b. All right. So the first thing that I need to really pay attention to here is that this is a subtract sign, and this subtract sign means change every one of these. It belongs to every term in here. So what does that do? Well, it changes every one of these to these terms: a negative 5, a negative 2a, a plus 3a cubed, minus a 6ab, and a plus b. Now that I have distributed this negative, I can just forget about it and say all I need to do now is combine the like terms. So what are alike? Well, I'm going to look for the biggest exponent because that's what I'm going to write first, because I should always write all these answers in descending order. So I'm going to have cubed here, and I've got 3a cubed plus a 3a cubed because I'm no longer looking at these. Okay, so 3a cubed plus 4a cubed is a 7a cubed. Next, I'm going to look at, well, what has the next highest degree? Well, this has a degree of 3, this has a degree of 0, this has a degree of 1, this has a degree of 2, remember, because I'm going to sum the variable exponents, so 1 plus 1 is 2, and this has a degree of 1. So maybe not so easy to tell AB, but we'll talk about that in just 1 second. So I'm going to do degree 2 next, so I've got a 2AB minus a 6AB, so 2 minus 6 is going to be a minus 4AB. Now, the question is, which do I write first, this A or this B? Well, in the alphabet, A comes first. So if you have the same degree, then you're going to write it in alphabetical order. So I'm going to now combine these A's and say -5 and -2 is going to give me a -7A. Then I'm going to say, well, this B is floating out here. It doesn't have anything to combine with over here, but it still belongs here because I'm going 3, 2, 1, 1. But in the 1 category, I'm going to go in alphabetical order. Okay, and then I've got this 7 and this -5. So 7 minus 5 is going to be +2. So this would be the simplified version in descending order of combining these like terms. Again, pay close attention when you have a negative that you change every sign that comes after it. And remember that in subtraction, the order matters. So this negative changes everything. All right, see you guys in class.